What is the effective capacitance between the points X and Y in the given figure? And there are 5 capacitors which are given. The connection given to be, it is a point X where we have a 1 capacitor, and then we have a point C, then we have a capacitor, it's given a point B, then we have one more capacitor, hence it is a point D or it may be Y. Then we have between A and B there are 2 one capacitor, that is C4, marked as C4, and between C and D we have one more capacitor. C and D we have one more capacitor. So we'll name these capacitors. It is a C1 and this is C5, it is a C4, it is C3, it is C1 and it is C2. So C1 to C5 there are 5 capacitors which are connected as shown in the diagram. So we can solve this only if we are able to rewrite. So how to rewrite? We know there are capacitors which maybe look like a series or maybe parallel. So unless you write a circuit we cannot write. So we'll rewrite the diagram. I'll consider the capacitor between B and C. So I'll take this point as C, and here we have one capacitor between B and C. So this is a point B where we have capacitor, that's C5. So therefore one point is B, other point is called C. Then I'll move from C to A. So C to A we have one capacitor. So this is point A. A is nothing but it is X. Then between A and B we have one more capacitor. So that is C4. One capacitor C4. And this is C4 between A and B. We'll move from point B to point D, we have one capacitor, that is C2. That is capacitor C2, and we'll reach a point D where D to Y is connected. Between C and D we have one capacitor, and that is C1. It is a C1. It's a point C and this is C1. So therefore we got 5 capacitors which are connected in a different way, and we rewrote the diagram. Between X and Y we have 5, and if you know this value, C1 is given to be, it's a 6 micro, whereas C2 is 6 micro, C4 also 6 micro, and C3 is 6 micro. Only C5, that's a different, and that is 20 micro. Since the capacitors across AC and CD are equal, similarly AB and BD are equal, it is equivalent to the balanced Wheatstone network. Balanced Wheatstone network. When it's a balanced Wheatstone network, the capacitor whatever we connected between C and B will not get a charge. Reason, point C and B have same potential. Therefore this capacitor is not at all effective. Eliminate that, remove that. Remaining is 2 capacitors from A to D. One is C3 and we have a C1. We got a point D, that is nothing but Y, and it is a point A, and here we will get a point X, and 2 more capacitors, that is C4 and C2. Now C3 and C1 are in series, C4, C2 are in series. We know these values are 6 and 6 series, therefore series connection it becomes a 3, because 6 into 6 divided by 6 plus x, so therefore half of that, so therefore we can write 36 divided by 12 is a 3. Similarly these two will be 3. So therefore capacitors between X and Y, we have a 2 capacitors, one is 3 micro and below we have 3 micro which are in parallel. So effective is only one capacitor between X and Y which is equal to sum of these two, it's a 6 micro. Therefore between X and Y the effective capacitor is 6 micro, and that is given as option A.